Hi everyone. In today's challenge, we have this problem shortest breed and the problem number is 934. Alright guys, so first of all, we are going to clearly understand what this problem say. After that, we are going to move to the logic part. We are going to see how we can solve this particular problem. And after that, we are going to move to the implementation part where we are going to implement our logic in C++, Java and Python programming language. Fine guys, now let's see what this problem says, right? So problem says you are given an n rows and binary matrix grid. So one thing is clear that we are given the binary matrix and the name of matrix will be grid and it is binary. That means it will only contain 0 or 1, right? After that, where 1 represent land and 0 represent water. So that means nothing guys. If I would say this is grid, right? And here in example 1, you can see this is 0, this is 1, this is 1, this is 0, right? So this 1 is nothing but we can say land and this 0 is nothing but we can say water. I hope this makes sense, right? An island is a four directionally connected group of buns not connected to any other ones. There are exactly two islands in this grid. So basically, it will say that if I will make it here, then you can say if I make it here, then this is nothing but this is island, right? So here also you can see there are two island, right? So there will be exactly two island in this example. Whenever you will getting a grid in our function, you are getting a two island only, right? Now whenever we can say this is an island, so this is one, right? If there is no, we can say more one connected to its adjacent side, means left side, right side, top side, bottom side, then you can see this is the only island. Here you can see here the left side zero, so we can't say. But if here would be one, if I make this is also one, then you can see that this is completely island, right? Why? Because this is connected to this adjacent. So we can say this is one island, and this one is also adjacent to this. So this is also island. So we can say this is completely a one island, right? So this is whole one island. I hope this makes sense, right? So this is now we are getting a whole island. So but here was zero. So that means these are not connected to each other. So this is a single island, and this is also a single island. Now they say that you may change zero to one to connect the two island to form one island. Now the main logic is here only guys. We are given the two island. Now just we need to convert into one. That means we have to convert 0 to 1 so that we can make only one island in this grid. And how we can do this? We can easily do this, right? After that, the main tricky part is return the smallest number of zeros. You must flip to connect the two island. See guys, now one thing we could do that we can convert zero, all zero to one, and definitely this will be only single island, right? There will no more than one island present in our grid if we do that. But we can't convert all zero to one. We have to convert the minimum number of zero so that our island will become a single, we can say, so that our grid can have only one island. So here you can see just we need to flip either this or this. So if I flip 0 to 1, then you can see I am able to make a complete one island. So I need to just flip 1 0 to 1. So this was the main logic. I hope you understood the problem. If you understood this particular problem, then definitely you can easily move to the logic part. If you still have any kind of doubt, you could not able to understood this logic or the problem, then you must need to understand the problem first. Then you can easily understood the logic, right? I would say go through the video once or go to the website of Leetcode and understood with a different example. Then only you can understand the logic part, because understanding the problem is the first part, right? If you understood the problem, then only you can understand the logic. Now let's see how we can solve this particular problem. What is the logic? So guys, the logic is going to be really simple. We just need to use a TFS, or we can say BFS, or we can use a both in our graph, right? I hope this makes sense. Why I am seeing a graph? You can't take it a graph as well. You can take it a matrix as well, because each cell is nothing but a node in this matrix, right? So that's why I always consider matrix as a graph, right? I hope this makes sense. Now let's take a second example and then understand our logic part, because this is going to be a really big problem to implement. So that's why I'm doing a little quickly. But logic you must understood it, right? So I'm not gonna do in hurry the logic part, but you should understood the logic part first of all. So this is our matrix right now we have, right? Now what I'm gonna do, I'm gonna say the logic is simple, just three step. First step, take for any island. And what does it mean take any island? Mistake if there's a here in example you can see that we have only one, right? If we can have more than one as well, right? So this is also one island. So this is also condition satisfied, right? You may have this thing, right? So let's take this part because you can understand the in detail as well. Because if I don't take it zero, then it is going to be really easy problem, right? You will definitely find out the only one element is present here, one is there. So we can make a single path here. And I guess this kind of similar problem is present in lead code as well, right? With another, we can say title, right? Okay, so now let's take it this one. So now we have two island here. We have this particular island, we have this particular island. We have to connect this to make a single island, right? So that we can flip as number of zero as we can, right? But if you will see orally or theorically, you can see that we can just simply connect this one. Okay, we can just simply connect this one. We can change this one, and we can see we have converted the single island. This make single island in just flip of two, and this is the right answer as well. But how this come? Let's see with this. So first of all, what we have to do, we have to take any island. You can take this island or this island. And what I mean by any island, taking island, that means you have to take all the ones, right? And this is nothing but cell. If I say this is 0 1, this is not 0 1. Let me do this. This is 0 0, this is 0 1, this is 0 2. This is nothing but we can say 1 0 1 1 1 2. This is 2 0 2 1 and 2 2. I hope this makes sense, right? So this is the cell number. So you can take any cell. So I took, let's say I took a first one, right? So if I'm taking a first one, so what I can say, I have currently two cells, which is nothing but 0 0 and 0 1. You can see that these two only have one, right? So I took a first cell. Now from first cell, where we can move? So this is nothing but in our queue, right? I'm going to use a BFS. And for finding this two cell, you can either use a DFS, BFS. That's your choice, right? Both are thing gonna give you this two cell. So once we found this two cell, right? So let me go to this particular top. So okay, so we have this two cell now. So what I'm gonna do, first of all, I'm gonna take first element, right? So let's write here this thing. So in BFS, I'm gonna take the first element and I'm gonna just see how many possibilities we can move, right? From 0, 0, where you can move, you can not move to the left side or top side because these are auto bound. And whenever you're taking these cells, you have to make them a -1, right? Or you can use a visited set and you can check it there if this is already visited or not. But for visiting, I'm using a -1, right? So here I use a -1, fine. And here from this cell, we cannot move to the left side, top side, right side, because right side is already -1. That means it has already been visited. Now we can move to the downside. This is nothing but we can say 1, 0. So let's move to the downside. From 0, 0, we can move to the downside, which is nothing but 1, 0. And after that, you can see from 0, 1, we can move to the left and right side. Not left. From 0, 1, we cannot move to the top left, but we can move to the right and bottom side. So from 0, 1, we can move to 1, 1 and 0, 2. I hope this makes sense, right? Fine. So in the first step, we have to miss all these nodes where we are reaching. They can only be we can only reach to all these nodes by just flipping a single 0. If this makes sense, right? Now from this level, let's see. From first of all, we are going to take 1, 0 node. So from 1, 0, we can move. We cannot move to anywhere. First of all, see guys, we have already traversed 1, 0 as well. So we can mark this -1. We can already traverse 0, 2, and we have traversed this one, right? From 1, 0, where we can move? We can move to the bottom side as well, right? This is autobound, this is autobound, or top is also autobound. We can only move to the bottom. This is nothing but 2, 0. So from 1, 0, we can move to 2, 0. And from 1, 1, now let's see from 1, where we can move. From 1, 1, we can move to, let me mark it this one. From 1, we cannot move to the top. We can move to the left side. We can move to the right side, right? So we can write here -1. Okay, from 1, 1, you can move to the right, 1, 2. We can also move to the down, which is nothing but 2, 1. Fine. And now let's see from 0, 2, we cannot move anywhere, right? From 0, 2, it is completely surrounded by -1 and autobound, right? Fine. Now let's see the next level. So that means this level, these all three nodes, we can reach. We can reach to all these three nodes by just flipping a 2 coin, right? Now we are at 2, 0, 1, 2, and 2, 1. So let's take first of all 2, 0. Okay. Now from 2, 0, where you can move? You can see if this is 2, 0. And guys, we have already traversed this one as well, right? 2, 1. So we have to mark -1. Now from 2, 0, we cannot move anywhere, right? Did that make sense? Because all these cells are surrounded by -1 or autobound. We cannot move left, top, right, and bottom, right? Now let's take a 1, 2. So this is not going to move anywhere. But 1, 2, can we reach to somewhere? From 1, 2, yeah, 1, 2, we can reach somewhere where we can move to the down as well, right? So if we move to down, that means 2, 2. Can't you see this 2, 2 has a value 1? So once we found a value 1, we are going to return whatever the value at the top set. So this is nothing but 2. So we can say, guys, we took this one step, two step. We just need to flip 2 coin because the next level is going to give us a 1. So we can say just we need to return 2. We need to split, we can say flip only two zeros to 1 so that we can reach to our next island. So this was the simple basic logic. I hope you understood the logic. First step, take all the islands. Second step, start BFS. Because BFS is the only best algorithm which give us the answer in the for finding a shortest path to in a graph or in a matrix anywhere, right? Whenever you need to find the shortest path, you just need to use a BFS. I hope this makes sense, right? Now let's move to the logic part and see how we can solve this particular problem. So what I'm going to do, I'm going to see first of all size. Okay, this is 125%, right? It's fine, I goes. So now first of all, what we are going to do, we are going to find a length, n comma m, which is nothing but length of grid of 0, n is nothing but length of, I could say, row, and m is nothing but column, right? So once this is done, we are going to traverse our grid for I in range of n, 14 in range of m, and here I'm going to say if grid of I comma j is 0, not 0. If it is 1, that means we found our starting of the any array, right? So if we found, we are going to run a DFS here, I comma j. and we're gonna make a status is equal to true. Why I'm doing this, I will tell you, and then we are gonna break it. So see guys, I have to make first of all a status variable that is nothing but initially would be false. Now let me tell you why I have made this function dfs as well. So define dfs, let me write dfs, and it's gonna take row and column, right? See guys, now I am just using a loop. I'm traversing over whole the matrix. I'm finding if anywhere I found a single one. That means I found a first part of island, right? Any island it could be. It could be first island or second island. I found the first part of it. So I need to find all the adjacent one. So I'm gonna run a DFS there, which is gonna tell us that what are the all the adjacent, right? And I'm gonna store in our queue. So I can make it our queue here, right? I can say queue is gonna be nothing but let's use a collection dequeues. Collection dot dequeue dequue, right? And inside of this queue I'm going to push all the nodes, or I can say all the cells which have one. So what I'm going to do, I'm going to say if row is less than 0, right? Or if column is if row is less than 0, if column is less than 0, or row is greater than or equal to n, or column is greater than equal to m, or we can say a grade of row and column is, I could say if it is not equal to 1, right? So we don't want to take it, right? We can directly say return it. But if it is not the case, then we can say append in our queue, queue dot append this particular row comma column, right? Row comma column. And after that you can mark them visited. So I can say row comma column should be equal to -1 now, because if it is -1 that means it has already been visited. After that run dfs on all the adjacent cell rc plus 1 dfn of r comma c minus 1 okay, dfs of r plus 1 comma c, dfs of r minus 1 comma c. Once this is done, we that means it's gonna q gonna give us all the nodes which are adjacent to this particular one, right? I hope this makes sense. So we have marked status, we have defined a status variable. Why? Because we want to, whenever we are finding a one, we are going to breaking it, right? And we also want to break this outer loop. So it will be done only if we have another variable status. If status is 2, that means you have to break. So okay, so we have find all the nodes of first island. Now we have to use simple PFS. So let's write a PFS. So we can say while what we can say, while we can say our queue is exist. So while queue is exit, we can say if no, not if, we have to find first of all size, which is going to be the name length of queue. We can say if not here also we can use for I in range of size, and why is it so? We are traversing on the first level, right? You can see that in if I show in this, you can see this in initially this was the first level, right? This makes sense. So we have initially this particular level. We are going to traverse all the nodes, then we will traverse all the next level, then all the new next levels, right? So we are traversing all these nodes. So we're going to say data is going to be not data. We can say row and column is going to be nothing but q dot pop left. Fine, pop left. And here we can say traverse all the direction, right? So for all the direction, I could say I comma j in 0 comma 1 first of all, then 0 comma minus 1, then 1 comma 0, then 1 minus 1 comma 0, right? So once this is done, what we are going to do, we are going to say if but we have to first of all find that cell as well. So we can say x is equal to row plus I. Let me write here x comma y is equal to row plus I, and g uh, c plus j, right? See guys, if you're still not getting this code part, don't worry, I'm going to summarize it later on. But here what I'm doing, I'm moving all the 4 direction, and I'm checking this if that first of all direction is out of bound or not. So if x is greater than or equal to 0 and y is greater than or equal to 0 and x is less than m, not n, and y is less than m, and we can say grid of x comma y, right? Grid of x comma y is not is equal to 1, then we don't want to take it, right? If it is not equal to -1, right? If it is not equal to -1, then only you have to take. And here you can check it if grid of x and y is equal to 1, that means we found a cell which is having value 1 now. So we can say what we can say, we can say fine, we can return our distance. And what is the distance? We have to define distance as well. So let's define here at the top before this while loop. So we can say what we have to done. So we have say here distance is going to be nothing but equal to initially 0. Fine. Now here distance we have defined it, but if it is not the one, means if it is not 1, that means it is a 0. And if it is a 0, then what we are going to do, we are going to push in our queue. Before that, we are going to say grid of x comma y should be equal to -1. Now push in our queue. So queue dot append x comma y. Okay. Once we have appended in our x comma, what we are going to do, we are going to say come out this loop. So we after this loop, we are going to make a distance plus 1 because we have traversed one level, right? So we are going to move, make our distance one more, right? After that we can return our distance, but this condition will never arise, right? We will definitely returning here. So let's see we have that we have done any mistake or not. So let's check out. I don't think so. Let's try to run this code and see whether we are getting our output right or not. Okay, and you can see I got an error that is grid, right? So grid is not defined. So where I have here, this is grid, right? So do we have any more error? Let's check out. And here I think there's one error which is none type, which is not valid, so we can say simply return it, right? But this should not be the case, right? So I am having somewhere right distance, so let's check it where we have done a mistake. If x is equal to greater than 0, y greater than 0, x less than m, y less than m. So you can see both are giving me an error, which is nothing but output 3, I'm getting a 2. So let's make it a size bigger, this one as well, and let's make it there, right? Fine. Now let's see what is the output we are getting. So we have done somewhere a mistake, right? Here also I'm getting 1, here also I'm getting a 0, right? So mistake is somewhere I could see. We are taking a pop left, we are moving all the directions 0, 1, 0, minus 1, 1, 0, and we are saying this fine. X should be less than this, y should be less than this. Here you can see that we are making the mistake, right? We are making x 1, right? We have to make x comma y is equal to 1. Now let's run this code and see whether we are getting a right output or not. And you can see that, guys, all the test case passed. So let's try to submit this code. And I guess we should able to submit this code as well. And here you go, guys. We have successfully submitted with Python. And now let's move to the next programming language. That is nothing but we can say, let's take it as Java, right? So I'm going to take a Java. And here in Java, what we are going to do, we are going to say first of all length. So int n is going to be grid of size. So we can say grid of length. And in n is equal to grid of 0 of length, right? So let's mark it 0 of length. Now once this is done, what we are going to do, we are going to say just use make a queue first of all, queue. And for what? For we can say this integer array, and here the name is q, which is going to be nothing but, let's keep it a q only. Q is equal to new. We're going to make a queue of linked list, right? First, this is clear. Now we're going to use a for int I is equal to 0, and before that, okay, let's make it this only, for int I is equal to 0 and I less than and I plus plus, and here also for int j is equal to 0, j less than m, j plus plus, and here I'm going to check if grade of I and j is equal to 1. If it is 1, so make a state is equal to true, and call dfs function, which is going to take I comma j comma grade comma q. So after that you can break this loop. Let me take a semicolon, and here in this loop you can check it. If state is true, then you can break this particular loop as well. Let's define here one function which is gonna return nothing, void. The name of function gonna be dfs, and here we're gonna say int row, int column, int here we can take a grid, right? So we can say grid, and what we are going to do, we are going to say here take a queue. So we're going to take this particular queue here, so we can say this is going to be nothing but our queue, right? So we have taken everything over here. Now once this is done, we are going to say fine. We're going to say first of all, if r is less than 0 means row is less than 0, or column is less than 0, or row is greater than we can say grid of size, right? So grid of length, and here if column is greater than grid of 0 of length, and here one more condition we need to check, which is nothing but grid of row and column should be equal to our one, right? So if it is not equal to 1, if it is not equal to 1, then we can simply break it, right? So we can say if it is not equal to 1, so simply you have to return it, right? But if it's not the case, then what you are going to do, we are going to say first of all append in our, where we are going to append it, append in our queue. So we can say queue dot offer, and we're going to say new int of this particular row comma column. Once we appended in our queue, what we can do, we are going to say call mark this particular grid. First of all, grid of row and column is equal to -1. We have marked this -1. Now we are going to call this tfs again for row plus 1, column, grid, and queue. Same thing, we are going to copy and paste it 4 times. I guess I have run it again. Shit. All right, no worry. Right. So there is shortcuts with control and control enter, so it run it, right? So row plus 1, row minus 1, row and column -1, and column plus 1 and row, right? So this is the 4 direction where we are going to traverse our tfs. So once this is done, what we are going to do, we are going to say simple, we have taken all the nodes which are in first island in our queue. So once we have taken all the nodes in our queue, we are going to use a bfs. So let's write here bfs. So we are going to say while our queue dot size is our queue dot you can say size or length. So q dot size is equal to, is not equal to 0, right? If it is not equal to 0, then you have to keep moving. So in this thing you can say int take a size, which is nothing but q dot size, and here you can say for int I is equal to 0, I less than size I plus plus. And what you are going to do, you are going to say take out the node. So I'm going to say first node and last node. So what I can take, I can take things, uh, let's take it first from a second node like this. I can take a row, right? So it would be an array, so we can say take an array right now, int array, and we can say data, which is going to be equal to q dot uh, not poll, we can say, like we can use a poll as well. So we can say poll. Once this is done, so we are going to say a row, int row is going to be nothing but data of 0, and int column is going to be nothing but data of 1. And after that, once this is done, so what we are going to do, we are going to say, and we have taken this thing, right? So what we are going to do, we are going to say move to the 4 direction. So let's define an array here, move 4 direction, which is going to be nothing but this thing. Say this is a 4 direction, which is going to be nothing but direction, which is going to be nothing but first of all 0 comma 1, then 0 comma minus 1, then 1 comma 0, then minus 1 comma 0. Once this is done, what we are going to do, we are going to say traverse over this array. So for int I is equal to 0, I less than, or we can directly say int this array, and here we can say direction, or we can say d of dir. So you're going to traverse over all this array, and we are going to say now current x is going to be nothing but d of 0 plus our r, and int y is going to be nothing but d of 1 plus column. Once this is done, what we are going to do, we are going to say check it if this is out of bound or not. So if x is less than 0, it should be x greater than 0, right? So if it is greater than or equal to 0, and if it is y is greater than or equal to 0, and if x is less than n, right? And if y is less than m, and last condition, which will be great, of x comma y is not equal to minus 1. If it is not equal to minus 1, then what you can do, you can say fine, this is a current condition, right? So we can say if grade of x and y is equal to 1, if x and y is equal to 1, then we can say we reach to the condition, so we can return that our distance, and we have to define distance as well, right? But if it is not the case, then what you can do, you can say if it is not the case, so you can say we are going to append in our queue. So we can say first of all, let's mark it visited, grade of x comma y is equal to minus 1, and now append in our queue. So we can say q dot append, it is not a python, so we have to use offer new int, and here we can pass x comma y. Now once this is done, we are going to increment our distance as well. So distance plus equal to 1. So we can do like this as well. And after that, at the end also, we need to return something to avoid error. So return distance or minus 1, whatever you can do here. And here I'm going to define a distance which is nothing but equal to 0. Now let's see, we have done at least right. Let's try to run this code and see whether we have done something wrong or not. I think it's fine. Like you can see that status, I have to use a define data type, right? So I have to say boolean status is equal to false initially. And any more error do I have? Let's see. All right, so let's see, do we have any more error? Yeah, we have one more error, that is out of bound. So that is nothing but, okay, we have out of bound over here. So it should be if equal to as well, right? Otherwise it will give out of bound, right? Now let's see whether we have any more error or not. You can see all the test case passed. So let's try to submit this code, and I guess it will get submitted as well. And in Java, definitely I try to avoid an error, right? Mainly I get an error in Java. Now let's move to the C++. So in C++, what do we have? First of all, we have to take n, right? And m. So n is going to be nothing but grid of, why it's not coloring it, n is nothing but grid of size. Fine, in n is nothing but grid of 0 of size, right? Now let's define a q. So q is going to be pair of int comma int, because we can take two value in pair as well. So let's take it here pair. Fine. Now what we are going to do, we are going to use a loop, and let's take it a variable here to avoid an error. Before for int I is equal to 0. I hope now guys you know this what we am doing. Int I 0, I less than n I plus plus. For int j is equal to 0, j equal to 0 bro, j less than m, j plus plus. And here I can say if grid of I comma j is at right here 0. Fine. Now guys, here you know this thing what we have done, right? We have traversed over this matrix, and we are checking whenever we are getting first time 1 in our grid, that means this is a part of first island, right? Now what we are going to do, we are going to call a dfs here with this particular I comma j, and we have to pass our grid, we have to pass our q, and after that we can say status should be equal to true, right? And after that we can break this. So let me write break, and here in this condition we can check it. If status is true, that means we have to break the auto condition as well. So we are breaking this particular for loop as well. Now let's define our function is. So the function is going to be nothing but, let's define at the top. So here function is going to be nothing but void, which is going to just run a dfs. So it's going to take a row, it's going to take a column, it's going to take a queue, first of all a grid. So let's copy this. Why to write again and again, right? So let's copy this particular thing and let's paste it here. Okay, and here I'm going to take a queue as well, right? So let's take a queue of pair int comma int, and here I'm going to give a queue name q, right? And guys, we can make this screen bigger by just moving this here, right? Fine. Now we have make a queue, we can done this whole thing. Now we have to go to check it if it is out of bound or not. So we can say if r is less than 0, right? If r is less than 0 or column is less than 0, means row is less than 0 or column is less than 0, or we can say row is greater than grid of size, or we can say not greater than, again greater than or equal to, right? So I can use a grid equal to as well, so both things are same. So we can say column is equal to grid of 0 of size. Okay, and after that you can check one more condition, that is grid of row and column should not be minus, right? It should not be -1 or 1. So it should not be 1. It could be -1, but it should not be we can say anything, right? The main thing is that we have to take all the nodes, right, of that particular path. We have first find a 1, so we have to take all the adjacent sides where we having a 1. So we are using a dfs, so we are just avoiding this condition. If we are finding a 0 or -1, just break there only, right? We want to take only 1. So we are going to say take out all the one which are connected to this one. So we can say if this condition arises, so you have to just simply return it. So we can use this breaks as only, we can directly return here, right? All right, so this is condition is done. So now what we are going to do, we are going to check it. Now what we are going to check it, we are going to say first of all, let's mark it visited. So we can say grid of this row and column, we are marking it visited. Now after that we are appending in our queue. So queue dot push, you can append it queue like this. So we are going to append it row comma column. Once we have appending column, we are going to call this info action, that is r comma c comma grid comma q, right? Now let's copy this particular thing and let's paste it here. Let paste it here and let's paste it here. All right, once this is done, now we are going to move to the old direction, that is nothing but we can say row +1 first time, second time row -1, and here column +1 column -1. So we are moving all 4 direction. This dfs function is going to give us all the nodes which are connected to this one, right? And which are one only. So once we are getting all the nodes of first element, so what we are going to do, we are going to use a bfs. So let's write a bfs and let's take it some space here. It's fine. Now let's go over thought. Here what we are going to do, we are going to first of all define a distance which is initially 0. Here we are going to say while our q dot size is not equal to 0, you have to keep moving, right? So we can say if it is not equal to 0, now just find out first of all size. This is not gonna be, let's keep it a length, length, which is gonna be q dot size. Now we can say for int I is equal to 0, I less than length, and I plus plus. We can say what we can say if, or we can just first of all find take out the first node from q, which is gonna be nothing but the first node is gonna give us what we can say q dot we can use a front as well, right? So this is gonna give us the first top node, right? So which is gonna be nothing but a pair. So we can use auto, and here we can use data, right? Anything you can use it, which is going to be the top most of a queue, right? And once we are not top most, we can say the first in a queue, right? And once we are getting a data, we are going to take out row and column. So we can say into row is going to be data dot first and column is going to be data dot second. So we have taken that thing as well. Now we're going to move to the old direction. So we have to define an array for that. So let's define a here only array. So I'm going to say int our direction array is going to be nothing but 2D array. The column is going to be show 2. So here I can say 0, 1 and 0, -1 and 0, not 1, 0 and -1, 0. When this is done, we are going to use this array here. We're going to say for int I is equal to 0, I less than 4 because 4 we are sure, right? Here we can say now current column, current x is going to be data dot first plus direction of dir of I of 0, right? And we can say copy this line and paste it here, and here direction of 0, 1, and this is going to be not first, going to be second, and this is going to be y. Now once this is done, we are going to say if this is not out of bound, so we can say if x is greater than or equal to 0 and y is greater than equal to 0, right? and we can say x is less than n and y is less than m. That means this is not out of bound, right? And one more condition we have to check it, if grid of x comma y is not equal to minus 1, right? If it is not equal to minus 1, then only we can move here and we can say if it is not equal to minus 1, then check it if grid of, so we can use a bracket, if grid of x comma y is equal to 1, that means we reach to the condition, we can return directly distance, so return distance. But if it's not the case, then you can say grid of x and y, mark them visited, minus 1, we mark them visited. Now we can say return directly, not return, just put this in our queue as well. So queue dot push, so you are going to push it x and y. Okay, now in the outer loop, what we are going to do, we are going to say distance should be equal to plus plus 1. And after that, you can simply return distance. Now let's run this code and see whether it's working fine or not. So let's try to see this code as well. And I think it should work fine, right? We got an error, first error here we forgot to use a one more, this particular one. And now let's see. Okay, do we have any more error? Yeah, we got a 0, right? Why it is so? Because we haven't passed it by value or by reference, right? Now it will not give me error, I guess, because the queue was initially empty, right? So it returned distance, so it will now gonna append it. Now let's see whether we have any output or we are getting a TLE. I hope we are getting a TLE here. So let's see what condition giving us here TLE. So Q, okay, so the condition is nothing, but we are not popping it, right? We are taking a first front element of Q, but we are not popping it from Q. So we have to pop it as well. So this is a condition which was giving TLE. Now let's see whether you can see all the test case passed. So let's try to submit this code. And I think it will get submitted, right? So you can see that we have some successfully submitted with the C++ as well. So we have solved this particular problem with Python, C++, and Java. And I know I was a bit fast in this particular video, so but I hope you can understand this particular logic as well as the implementation part. And still, if you have any kind of doubt, you can write in the comment section. I'm always there to help you. And if you learn something in this video, don't forget to hit the like button and subscribe my channel. Meet you in the next video.